jumps out to me, but we'll see.
Alright, so let's see, what did we do last time? To do for next week. Nice. So, we should look at with statements. So let's see. That would be compound statements, I guess. Here. So the problem here is this look ahead. I don't know if you were here. I think you left
Last
early,
week,
right?
no, Sunday can make it.
Right. So, this is that the with statement has an optional async, then there's a with, then there's a rather complicated thingy here, which is unfortunately complicated because all this says is you can have parentheses around it. Otherwise, it's just a comma separated list of with items, right? This is something that would be nice to somehow simplify, but I don't really see how.
Right, yeah, so I would have expected it to be like just invoking another rule instead of just putting it all like maybe a function call explicitly, right?
No, this is with, and then there's the context managers.
No, I know, but like this seems a bit not redundant, but this rule is very similar to other rules, and I would have expected it to invoke those instead of going all the way to say every single token, right? Does that make sense?
No, I think with items are pretty special because they do have this as.
Right.
I think you can have that in for statements, but also remember that in the grammar itself, these have actions attached. So if I look here,
you're right.
This has some C code, which will probably not be the same even if the syntax is the same as a for statement.
Yeah, fair enough.
Right, and yeah, the expression also is different than a for. I don't know where else this would be. But what I'm looking at is this, you know, you have something and there are optional parentheses around it. And we don't really have a readable way to express that because you have to say, you know, either there's an opening one, then the thing, then a closing one, or you can have it without the parentheses. And even if you do like syntax diagrams, it'll be the same, unless we had special syntax for, you know, you can put parentheses around this or not. But that's not the point currently. Currently the point is here. So you have expression and then as and some kind of target, and then you're supposed to have either a comma or a closing parentheses or a colon.
Right.
And this look ahead is actually not necessary because after a with item you can have a comma and then parentheses or this comma that's between successive with items, or a colon, right? There's nothing else that can follow the with item. So this is not necessary. But the problem is writing code to detect that. And that will probably need some compiler tricks or some stuff you'd see in a grammar textbook, which I haven't read for quite a while. So what are we looking at here? So this is actually an optional thing, an optional sequence that ends with a look ahead. Basically what we need is to verify what can come after this rule. And I guess to do that, we'll need to look at the entire grammar.
Oh no.
Right? Because what can come after this rule? Well, this rule is part of a sequence. So the things that can come after it are the things that can come after this sequence. And the things that can come after the sequence are whatever can come after this optional thing, which is whatever can come after this with item. And after that, so that appears inside the gather thing. So after the with item, we can either have the separator or whatever comes after the gather in this sequence, which is either the comma or the parenthesis. And the same thing here, where we need to look at whatever comes after this this choice in its sequence, which is this. This is kind of mind-boggling. It's probably not a good thing to do on the stream.
Yes? Let me see if I can do some quick googling to find what I remember the term production item. So maybe there's
Maybe we should study some literature. Production item.
Yeah, I remember that term specifically, and I think I found LR1 grammars, which I remember, but I don't remember what they mean.
Could you send the link you find?
I didn't, but I can. Is there a chat here? There is a.
There's a chat here somewhere.
It's from ECU, it seems. We always bring the notion of following tokens much closer to productions that we use them. That's pretty much perfect, actually.
Following tokens. Yeah, that's some notion I remember from school, right?
Yeah. I am in the same boat. I remember next to nothing from my compiler classes.
Yeah. So an LR1 item has the form IT, where IT is an LR0 item and a T is a token. I think I'll need to remember a lot more than I do. So
I also found the LR0 class if you want. So I'll just send it here, just in case.
So LR0 item is... So LR stands for left recursive, doesn't it?
Maybe.
Nah. Probably not.
Bottom up parsing. So this is tokens first. Is Python a Python parser, C Python parser, a bottom up or top bottom? Top down.
Oh, left to right. Left to right. Left-right parser with 0 look ahead, and this is a left-right parser with 1 token of look ahead.
Oh.
And I think Python's grammar used to be LR some constant, but it switched to PEG, which basically has unlimited look ahead.
Oh.
And some other priority rules. Rightmost derivation in reverse. Okay, it produces a rightmost derivation. it does a bottom-up parse, right? So it recognizes the lowest level details first. Makes sense. Not a top-down LL parse. So yeah, top-down parsers are the ones that are easiest to write. Oh, maybe Python had LL, not LR. To avoid backtracking, we're allowed to look at some tokens in look ahead. Yeah. So if you don't have any look ahead tokens, that's probably the easiest LR parser you can do. And if you add one, I don't know what this dot is.
This is the dot is the kind of like the cursor.
The cursor.
Whatever's to the left of the dot has already been processed.
Right. Oh, okay. So if you have a production like this, it'll expand. It'll basically add that out. So that's like a mathematical construct to keep track of where you are.
Yeah, exactly.
Ah, nice. Alright, so that as the dot moves, the token T remains attached to it. So there's a look ahead action when the look ahead token is T. Token is a token that can follow A in the context in which the A occurs. This does not suffer from the difficulty of using the follow set. Oh, follow set. That's a term we might want.
Follow set. Yeah, I remember that.
We should probably do like a little literature review rather than a web search for this. Will you actually let me do this? I trust the PDF viewer. Should be okay. So follow X, what terminals might come after the non-terminal X? This is exactly what we want. Problem is to find it. So the first sets, we actually have the first set already. I think.
That's sweet.
So there's the node has get possible start tokens. And we've implemented that for everything that needed it. So not all of them have it, but for the current grammar, whatever needs it, we do have this method. So that will be the first set, and let's see how to do this in math. So first of a terminal is that terminal itself, obviously.
Makes sense.
First of a non-terminal looks at all the productions of A, and there's a bunch of these, and I guess we look at the first in here, and
I assume lambda is the empty string.
Yeah.
Because I learned this with epsilon, but
Me too.
I guess that's fine. Huh.
Yeah, I also used to epsilon, so this is weird.
Yeah, that's weird. And first of A is okay.
So let's see empty string. Denoted with epsilon or sometimes with a lambda. Yeah, so
Ah, okay.
okay, why
Neat.
not? Uh, yeah, so this is pretty much exactly what we have, but we have more kinds of productions than the formal rules here. So we have a sequence where it's basically the same thing. We use none to denote the empty,
Makes sense. Makes sense.
like it can be empty,
Mm-hmm.
which so we have to do the whole for loop as long as none, item can be empty. None is still in there. If we find, well, whenever we find the first one that cannot be empty, we discard that none. Otherwise, we keep it in. Right, and then what is here? So we look at all productions. So I can expand to more things in the theory. So we model that with the choice. Now we basically update the set for all items. Okay. Computing first set for an arbitrary strings. Works the same way. Alright. And follow sets. So follow will find all productions that have this A on the right hand side.
That's easy. There's only two, or one, or one.
Uh, yeah. So the problem with this is it's just an example,
Oh, okay.
right? So we basically have to look at whatever includes this with item, which we can do.
Mm-hmm.
And then X so yeah, whenever we have a sequence, follow of A needs to be updated with the first of whatever follows it without the empty thing.
Mm-hmm.
And if there is the empty thing, we need to update it with the follow of X.
Right.
Yeah, that makes sense. And if there's no beta,
I mean, I think that was implied, this third item, no?
yeah, basically, if you set this beta to lambda, then you
Yeah.
just have two rules. Follow X never has this lambda in it. Okay, so mathematically, this is very elegant, as you would expect from mathematics.
Yep.
Now the problem is we have a lot more stuff than just productions, right? You have choices and sequences. So what do we do? What do we do in our model? Let's see if I guess the example is just follow theory. And of course, there's no guarantee on this stream that I'll actually come up with something useful. Okay. So well, let's do a test-driven sort of approach. So what we need to do here is look at where is this? Look at positive look ahead, and wait, how did we remove? Where do we use get possible start tokens? And simplify subsequence. All right. So yeah, if a positive look ahead is followed by something else, then we look at the possible start tokens of that something else. And if we find something, then the look ahead is redundant. Yeah, that doesn't really deal with the next node matching the empty string. Which we can probably do later. There's much to do here, but I guess what we need to do is maybe do it in the simplification of the positive look ahead. So how do we simplify this? Let me. What? What? Oh, simplify should return self, shouldn't it? Yes. Oh, maybe you should call the super. So if I look at all the positive look aheads we have, like this, they basically all have one token in them, or they have several tokens.
Well, yeah, so semicolon.
Yeah, there's one exception. Now they have a choice of tokens or a single token.
Where does semicolon come in?
Oh, the look ahead for a semicolon. Let's look at that. So that would be
Might not be a look ahead. Might be straight up terminal.
Oh, that's negative look ahead.
Oh, okay.
Oh, here it is. Delete statement
That's weird.
needs to be
Delete.
followed by end of the statement.
Yep, makes sense. I thought you were looking specifically at lookaheads for the width item.
The what?
The width item, not just
Uh,
all lookaheads in the grammar.
yeah. Well, I would like to find a general rule for this because there's a lot of these look aheads, I think.
Yeah.
Let's open all of these again. Oh, I don't think they show up here, do they? No. So well, should we look at only the width? No, there's a lot of those. So this is the one for the width.
Mm-hmm.
Otherwise, so this is the one for the delete.
Mm-hmm. Oh, there's another one similar to the width one.
Yeah, I think that's just a duplicate.
Oh, okay.
I'm just calling it at a random point. Calling the print at a random point. That's probably gets executed a bunch of times. But this right, there's this colon. There's this colon which is important actually. So yeah, I guess one thing we could do is somehow change the grammar to say now this is just an optimization. It doesn't need to be in the docs.
Hmm. What would be the downside?
The downside would be that people would get it wrong, which happens.
But if it's
But okay, let's see where look aheads happen in the grammar. I think I've done this exercise before, but okay, for simple statements. Oh, for simple statements, we've eliminated the look aheads already. So they start with a look ahead for the keyword. So I don't know, race statement starts with a look ahead for race, and we've eliminated that with the rule added earlier. So all of this, even a function definition which has 3 tokens it can start with, we know all of these are not important. Then there's this one for the del statement, which is at the end of the rule, so we haven't really eliminated that. We need the follow set for del statement. Then there's a bunch of them in argument parsing, which need to stay there. Those are actually important. There's the one with in the with item. For strings, we've probably eliminated all of that. Let's see, Adam. Yeah. So yeah, if it's in the beginning or in the middle, most of them are already gone with the rule added early. So now there's more argument parsing. There's this for arguments, which is probably important. Then there's this T look ahead. Which we probably want to eliminate eventually. But I don't think that's too important. And the type comment, I think we are ignoring that. Right, so yeah, the delete and with are pretty much the only ones we need to care about. So do we go through this interesting exercise in eliminating these look-aheads? How would that even work? So there's with and there's delete. They both follow a non-terminal, which I guess is good. Yeah.
Yeah, I gotta be honest, I don't know how to do this at all.
Well, I will try. So let's do it for the case of following a non-terminal. So we can try to get the follow set of the non-terminal. I think this is the only thing we have in the PDF, right? Follow of non-terminals only.
Yeah.
All right. So we need to go in the sequence simplification and if we have a non-terminal, how is that named? Non-terminal? And after that we have this positive look ahead with a choice or a token. Then we get the tokens we get the tokens from the look ahead. And then if this non-terminals follow set, I'll get contains only these tokens. Nothing more. Then we can remove that look ahead. Does that make sense?
Mm-hmm.
Is this subset? I guess it is. If oh, it's superset. All of the tokens in the look ahead need to be in here. Right.
Let me just double check it in my head. I'm a bit slow today, sorry. Hang on, I'll get it. Is superset? Yeah. Yes. Actually, no, it's subset. Because if the follow set contains items outside of the look ahead, then the look ahead is actually doing something
right.
because it's filtering.
Yeah. Good catch there. All right. Perfect. So we have our failed test. A non-terminal object has no attribute get follow set. Obviously.
Oh. Right.
So let's go to the non-terminal. And what do? So we find all productions that have A on the right hand side. So we go through all the rules and do this on them, I guess. So for each rule in the rules, so our productions don't have a string like this on the right hand side, but they have a tree, right? So this will be a bit more complicated. I guess we need to consider all the options. Let me write this here just to keep it on the screen. So what is this rule that we have? It can be terminals, non-terminals, tokens, stuff like that. So let's match that rule, and I'll write the last case first. We should get a better error now. What is this? And right, this rule says a dict, so you'll probably need both the name and the right hand side. Maybe not. keep it to the rule. Can add the name later. Alright, so not values. So, not implemented errors. Sequence of items. So I guess in here we need to go, if it's a sequence, we need to I guess handle each of the items separately. But if one of the items is this non-terminal, then we need to look at the first set of the following thing. Is that right?
I believe so.
All right. Okay. So we'll need the current thing and the following thing. So let's zip the items with an offset list of itself. So if this is easier to write with a match case. So if the current item is a non-terminal with the same value as self, then we need to add to the follow set we're building, right?
Yes.
And we update it with the following things. Start tokens. Okay. Otherwise, we need to go deeper. Right? That sequence can have a choice or a tree of stuff, and one of those could contain the non-terminal we're looking for.
Yes.
So we need to handle this. I can see a lot of bugs in there already.
A lot of nesting. There's a lot of nesting.
Yeah, it's yeah.
Well, I mean, there are a couple things you can do, but I'm not sure they're worth it.
Like what?
Create a new subroutine. Just an auxiliary function. A equals B, B equals A.
Yeah. So there is a lot of I don't know if simplification, but like readability improvements that we could do. I don't really want to make a subroutine just yet, but if we can think of a good name for some of this, maybe it would be better. maybe it would be good to give to like put a name in.
Mm-hmm.
So because one thing I see here is that the possible start tokens can include the empty string, right? Which
Yes.
we're not really handling here. So I think what we need to do is just go through the current thing and do a similar thing we did before. So if if we see the non-terminal we're looking for in the sequence, so that's this part. So we have found the A. We need to update our set with the first of this rest. But if we find a lambda, then we need to look at all the rest, right?
Yeah.
Okay, so we'll need the current position. We go through each of the following items after the one we found. We get the following tokens, right? If they contain this none thingy, which is our code name for lambda, then we basically do nothing.
Don't we need to?
So if we don't have the none here, then we break.
Yes.
Otherwise we go on, right? And we need to do this update before that.
It makes sense.
And I really like how this mirrors this one. Right, so we update our set with the start tokens without the lambda, and if we find the none, then we're good. Now the problem now here is if we go through the entire sequence and find that this could continue, all of the following sequence can be a lambda, right? So I guess this is this rule. So if lambda is part of the first, then we need the follow of A. No, the follow of X. Right? Does that make sense? Or I guess we've reduced that to here, right? So if this rest of the sequence can be nothing, then we need the follow of X. Now the problem here is we don't have productions. We are now deep inside a tree. So I'm tempted to use an else here. Do you know what for else in Python?
Oh yeah, for else. Yeah, the one feature Guido regrets implementing.
I'm sure there are more. Uh, let's just use this for a not implemented error and see it when it hurts us, right?
Yeah.
So this could actually be a string for the not implemented error. All right. So we have
Is there a, wait, is there an error? What's wrong with the rest of the sequence being empty?
So if the rest of the sequence after this non-terminal can be empty, then we need to look at the follow of x. So what can come after the
Oh,
sequence legally, right? And
right.
that'll need some thinking, so I just punted that.
Yeah, that's fair. That's fair.
Uh, it's like test-driven development here, right? Run into a not implemented error. So there's an optional with a non-terminal inside. So we're looking for what can follow an optional item. And I guess we just need to recurse inside that optional. And it'll give us a non-terminal. Yeah, I guess I really need to think more about this than just write the code. But here I'm basically recursing or traversing the tree, just calling handle rule on everything I find. If I find a non-terminal with the same value that I'm looking for, I'll need to handle it. Otherwise, I don't really need to do anything. That non-terminal is not interesting for me, right? If I find a token, that is also not interesting for me.
Wait, it's not? Wouldn't that immediately go? Oh, token. Sorry, not.
Right. So yeah, what I'm doing here is going through all the rules and finding this non-terminal inside them.
Yes.
So there's 0 or more. In case it's like this, or 1 or more. I will definitely have to rewrite everything here once I know what it should do. Alright, next up there's this choice. And I guess all I do in choices is handle each of these alternatives. There's negative look ahead. Negative look ahead. Negative look ahead only limits what can be matched, which means we can ignore it, basically.
Yes.
Right? If
yes.
the follow set contains more things than we need, then we don't get the optimization that we could have had, but that's okay. Right, so we ignore negative look aheads. Yeah, for gather we need to handle everything. And now we see that positive look ahead has no attribute get possible start tokens. So yeah, this is one result of the test-driven development, that we didn't implement this method for everything. So before I go to implement this, does this make sense?
Okay, let me double check. Which part specifically, or everything?
This whole thing. So here we. This would be. That's a comment. Go through all the rules and find.
So match rule, if it's a sequence.
So basically, all that we're doing here is traversing the tree.
I think I'm lost in the logic. Why are there two for loops that are...
Yeah.
That are iterating, like, why is this O squared? Is my question.
Oh, you mean this one?
No, the one above. Like line 662 and the one next to it, the next four.
Oh, right. So this one is looking for the correct
There's a lot
non-terminal.
of noise going on. I'm just gonna mute myself.
Sorry.
You can go on.
So we have a sequence of items, right? So this one is looking for the correct non-terminal, right? So if I go back to the with item, we have, for example, this sequence, and what do we have? Let's say we're looking for what can follow the expression here. So we're looking through the sequence and looking if we have the expression. And once we find it, we need to process the rest of the sequence to see what can follow this. Does that make sense?
Right, makes sense.
Right. So this one is looking through the items to find the non-terminal with the given value. right? And now we need to go through the rest of the sequence. But we only go through as much as we need until we get something that can be an empty string. Right, so
Yep, yep, yep.
yeah, that's right from the PDF, right? So uh, the first, yeah, this one, the first of the beta here. Where if there's more stuff in the beta, and the first thing in the beta can be in the empty string, then we also include the first of the next thing in the sequence, and so on. If we get to the end, then we're in trouble currently, but we'll see how that plays out. Right. So for the sequence, we're currently doing something a bit complicated, but for all the other ones, we're just walking the tree and calling handle rule for everything we find in that tree. All right.
I think it makes sense. Yeah.
So far, I know it's there's still a lot to do, but now let's implement get possible start tokens for positive look ahead. So let me find positive look ahead here, and we define get start tokens for it. What's the signature of get possible start tokens? It takes rules. So what can a positive look ahead start with? Exactly nothing. Right? It says 0. It matches nothing, so it can't start with anything. It only matches the empty string. Same for negative look ahead here.
Mm-hmm.
And I don't think I need this simplify here anymore. Right. Maybe we can consolidate the look aheads a bit.
I thought that was done or now that you done that. Oh, positive? No. Oh, just look at. Oh, I see.
So the only difference in the two is this. Right.
Okay. Might need to run the tests again just to make sure. Oh, right.
Yeah, tests run whenever I save this, and they currently hit this not implemented error. The rest of the sequence may be empty.
Oh, well.
So what does it mean that the rest of the sequence may be empty?
I don't like.
Here.
Is there really a special case in this case? I think we just let the follow set be that, and that's it.
So that's this, right? If the rest,
oh right, of course, of course.
If the thing after the A can be empty, we need to take the follow of whatever the A appeared in, right?
Yes.
So,
yes.
Since we're walking a tree here.
Actually, hang on, wait. Is that the case? You know, I'm a bit. Sorry, I'm a bit slow today.
Oh no. That's.
I'm still. Why would the? Because wouldn't you, in this case, right? Wouldn't the follow of A use the follow of X to calculate itself? Because of that rule?
Yes.
So isn't this a circular dependency?
So we're computing follow of A.
We are computing follow A. Right, of course. I thought we were computing follow X.
And to compute
Well,
the
if we're
follow of
computing
A, we
from
need to walk the entire, like, walk
yes,
all of the productions. So we have to walk all of the rules.
right. And can we not get the x from each of these? Oh, we need to redo the last iteration, right?
Uh, so the problem with the theory here only has productions, right? So it only has productions in the form non-terminal expands to a string,
Mm-hmm.
right? But we don't have strings here, we have trees,
Hmm.
right?
And does the tree not? Oh.
So we need to do
Hmm.
something different since we're traversing trees, and maybe
Do we not store which non-terminal generated the subtree?
so we don't store it, we walk the tree. But what I
Oh,
was
right.
thinking of is we can return some kind of flag that says, I need the follow. I need the follow set of whatever included.
We,
Uh,
we could return an object. We could return a tuple.
so we're
I
we're
don't think
updating
the error is the way to go.
we're updating
Sorry,
the
you go on.
the result here, and
Okay.
so the handle rule function, or maybe this should be just handle node.
Maybe we can signal like since you're removing the empty string from the result on update, maybe we can just include the empty string if the follow said could be like the following string could be empty.
Yeah,
That's how we
that
signal a little.
that was actually my thinking. We should signal, but not through the result, which is like basically global at this point to the whole operation.
Yeah.
But we need to signal it. Uh, we can signal it in the return value.
Yeah, a compound return, I don't think it's ideal, but it's easy enough to do, right? And easy enough to document that I don't think it's going to be a problem.
Right, so let's say handle node returns true if the follow set of node, this is the argument, should be included in the result, right?
Mm-hmm.
So we match the node here. If we have a sequence and we get to the end, then we return true. Well, we can't really return true. There might be non-terminals, more non-terminals, but no, if there are more the non-terminals we're looking for, and we got to the end, then everything we're going through here will already be included. So here we just return true from the whole function, right?
Yes.
Alright. So now handle node has a return value which we need to honor. So so in this case, if the sequence has something that included the non-terminal and returns true, which means we need to include the follow set of node. That means if this is true, then we need to do the same thing as here. Does that make sense?
Yes, I think.
So let me just set a flag here, and then move this loop in here. Right, and now if we find if none is not in start tokens, then we break. Yep. And we need to initialize this to false. Right? So we add the follow set if either we find the non-terminal itself right in the sequence, or if we found it somewhere deeper. Right?
Yes.
That's looking good. Right. Okay, now if we have an optional let's break out all of these and consider them individually. So here we need to handle the node itself.
You deleted, you left optional in all three of them.
Sorry, wrong ones. Whoops. All right. So if the item is optional, then what do? So this returns true if we basically find the non-terminal we're looking for inside this optional. So should the follow set of this optional be included in the result? Yes. Right? If the follow set of the item inside should be included, then the follow set of this optional itself should be included as well. Right?
So, off-topic question: how performant? I know this is not the point, but how performant are the match statements in Python?
How?
How fast are they?
I don't know. I guess you'd have to measure that, but
I know this is not the point. It's not important, but I'm just curious because Rust is compile time, right?
Yes.
This one.
So yeah, in Rust.
Can't be compile time.
I mean, yes, in Rust it's compile time and it has restrictions, right?
Yes.
In Python, it's basically is instance.
Oh, okay.
And so this is instance, and this is an equality. So basically, as performant as writing it out.
Okay.
If you don't have the feature.
Not as bad as I thought.
Right. So now we have these repeats. So if we're repeating the item, then the follow set of the item contains the possible start tokens of the item itself. Does that make sense? So I do result update get possible start tokens. Rules, and well, I don't want none in there. I handle the node, and since this is 0 or more, no, yeah, I need an if here. So let's see. If the follow set of the 0 or more should be included in the result, then I need to include the possible start tokens of the item itself. If the item can be empty, that doesn't really matter. But I do need to include whatever can follow the 0 or more. Does that make sense?
Mm-hmm.
Right, and if this is false, that means we didn't really find anything important. For 1 or more...
wait, so shouldn't it return false in that case?
So if handle node returned false, yes, then we return false. Which is implied we go to the end of the function, so let's not really do that. For 1 or more, I guess it's the same thing. Yeah, probably. Right. Now if we have a choice and one of the alternatives in that choice signal that we need to include the follow set, then we need to include the follow set of choice itself, right? Like we start with false. If this is true, then we set it to true, and then we return that, right? Or this could be rewritten as just any. Let's not do that. We need the side effects here, so let's stick with a for loop. Now for gather. So if the item is found in the separator,
aren't separators always terminals? I guess not.
Yeah. Yes.
How do we even test that?
Yeah, we could definitely do a match. I mean, you tested with an is instance. Right. So if the follow set of the item should include whatever follows it, then we definitely need to return true, but we also need to include the possible start tokens of the terminal, right?
Yes.
Sorry, the separator. And if the separator could be empty, no, it can't be empty. It's the terminal. But in case that could be empty, we need to also include the start tokens of the item itself.
Yeah.
So let's not worry about that, because right now we know it's a terminal, but when we get rid of this not implemented error, we might not remember about this one. Okay, any more? Wait, did I call handle? Oh, handle node here. Right, and that leaves this call here. And what do we do here? This is the top level rule. So we need the name. And we need to look at the follow set of another rule.
Oh boy.
So I guess we really need a non-terminal with the name get follow set.
This smells of infinite recursion, doesn't it?
Yeah, this can definitely have a mutual recursion or something like that. But yeah, now we can return the result and see where that takes us.
Oh, just wait. I just realized you're not doing a compound return. You're just doing return a boolean or a set.
Oh,
right?
So there's a function here, right?
I think I got lost in the indent levels. Sorry about that.
Sorry. So there's handle node, which returns
oh, right,
booleans.
Yes. Yes.
And
yes,
after we define it, we call it on all the rules.
Yes. Okay, I see.
And then return the result that we've been building throughout here, right? So this is
yes, that makes sense.
We set it the empty set, then we do the whole thing for everything, and then return that. Right. So obviously, I didn't write bug-free code, so there's nothing called There's nothing called terminal. We call it token. And we found self here. Right, we found self somewhere, which means the follow set of whatever we found, the follow set of this node we're looking at should be included in the result. That's what we're looking for, right? So
Mm-hmm.
now we just return true, and we run into optional not having get possible start tokens. So where is optional? So the possible start tokens for an optional thing are the possible start tokens of whatever is inside that optional.
Mm-hmm.
And it can also be empty.
Yes.
Right. So now we have not implemented error for positive look ahead. So what's so we're looking for this non-terminal in a positive look ahead, and we'll not find it there because positive look ahead matches nothing. Right. And now we see that a token has no attribute get follow set. At line here. Which is interesting. Wait, no token is a non-terminal? Oh, I messed up the match statement. I don't really like the syntax and semantics of the cases where if you do an instance check, that you have to have these parentheses, otherwise it assigns anything. Right, now 0 or more has no attribute get possible start tokens, and that should be the same thing as optional.
Mm-hmm.
Right, it can also be the empty string.
Yep.
And now we have maximum recursion
Yep.
depth. That was bound to happen sooner or later. So,
Let's see, which of the recursive calls is it though?
So,
Oh no.
the get follows it. I think it's here. And
Yeah, that makes sense.
there's a bunch of handle nodes, but that's because we have a deep tree, I think. And here's the recursion, get follow set, right? So what do we do here? So let's look in here again.
Can you go back to the code for it a little bit?
Right.
Just a second. Is the rules variable all of the rules or just?
Yes, all of the rules.
Then you need to keep track of which nodes you've already expanded.
Yes. So
along with the follow set, total follow set.
Yeah. So that's one thing I don't really like about the mathematics here, because this looks like an algorithm, right? But it has this thing here, which if you take it as an algorithm, it'll just recurse forever, right?
Yeah, it's like
So
I learned a little bit of Prolog.
Yeah, you need to already know follow X to compute follow A, but if they depend on each other, that doesn't really tell you what to do.
Yeah, I learned a little bit of Prolog in college, and like conceptually it's very pretty, but when you start to think about what it's actually doing under the hood, it's a nightmare.
So what do we need to do here? So we keep a set of all the rules we've already seen, and whenever we call this getFollow set, let's call it rules considered, right? Like if we've already seen this, in this run, yeah, let's do it like this. Then call this getFollow set recursively. Does that make sense?
Mm-hmm.
And that will now be an argument.
Yeah.
And if it's none, then we initialize it with an empty set.
Mm-hmm.
Right? And we always add
Self or self with
self.value.
value.
Now we could add self because the data class probably should probably have equality.
Yeah,
but
frozen
yeah,
data
value,
classes, I'm pretty sure have a hash.
Value is the thing we're looking for, and it's the name, right? So it's what we're checking here. Yeah, so the name is what we have. Wow, this is a very long line. Right, what does that give us? Ooh. So that ran without errors, but it didn't remove the look ahead we wanted to remove. But we have handled infinite recursion in here, which is great. That's sad. Okay, let's see. There's a non-terminal here. And a positive lookout, just add a print statement. What's the non-terminal? What's its follow set? I should probably not have this in an if, that doesn't trigger. And what are the tokens? So, del targets, the follow set is this, and the tokens are just new line and oh, damn it. So where does this? Let's look at del targets. That's simple statements. Del targets. Right. So there's this look ahead after del targets. And it's at the very end of a del statement. But what we're doing is we're looking at whatever can follow del targets. And using that to see if we can get rid of this look ahead. But we're looking at all occurrences of del targets in the entire grammar. I guess that's the problem. So if we look at all the occurrences of del targets in the entire grammar, it's here.
Is it possible that it's
but also
trying to find the follow set before the grammar is fully initialized?
No.
Okay.
It is possible that it's trying before the grammar is fully simplified, because it's part of simplification, but that
Right.
shouldn't be a problem. Yeah, so the problem is we should really look at, what can happen here at this point in the grammar, right?
Mm-hmm.
But what we did instead is look at what can follow del targets. And there's another rule that says del targets can be followed by a parenthesis.
Yes.
So we need something else.
I think it's just that in this case, like, the look ahead is actually doing something. I don't think it's an error.
Really? Wait, del targets is defined as del target plus.
What is del T Adam? Del T N, del T N. Or,
It's
okay,
one of
so
the
it's
possible del targets.
Jawohl. Okay, so I'm being called here, so I need to go soonish. But let's try to resolve this first. So what is del
So
T
we
Adam?
need to look at where del statement is used, basically.
Mm-hmm.
Right, and a del statement only appears a simple statement which can only be followed by semicolons and new lines. Right?
Okay.
So this is for the entire delete statement. That can only be followed by a semicolon or a new line, nothing else.
Okay,
There's something
sense.
different here. There's some garbage after the del statement. Right? There should be another del target, like a comma something, but somebody forgot to put in the comma.
Mm-hmm.
Like if you do del AB without the comma, I think this is what'll make the parse faster. faster for that or something like that. Yeah, so the problem here is we were looking for the follow set of the preceding non-terminal, but what we really should do is to look for the follow set of the look ahead itself.
Oh, right.
Right? Yeah.
Yeah.
So since
Yeah.
you need to go, I'll put that as a comment for next time.
Okay, yeah, I kind of need to go. Well, thanks for the
And
stream. It
see
was
you
very
next
enlightening.
week.
And we'll see you in next week.
Right? See you.
See you soon, and good luck recovering. Not good luck, what's the expression? Anyway, you gotta have a good recovery.
Thanks.
Bye.
Goodbye.